In this video, we're going to complete example 2 and we're going to learn how to add and subtract fractions. You notice the question actually just says to simplify. So what we're doing is we're adding or subtracting the fractions and then simplifying. Adding and subtracting fractions can be very challenging for students, which is why I'm going to be covering 10 questions. On this slide, I've got questions A and B. I'm actually going to be going all the way to question J. Before we get into example 2, I want to talk about these 2 dot points above. And to illustrate these 2 dot points, I'm going to start with a really basic example, such as 1 over 8 plus 2 over 8. What do we get when we add these two fractions? Well, you add the top two numbers, the numerators. 1 plus 2 is 3. And then the denominators, which are both 8, remain the same. And we get 3 over 8. And you'll notice in dot point 2, it says that you need the denominators to be the same before you can add or subtract, which is what we had here. So what do we do in a situation where the denominators are not the same? Let's say we had 3 over 4 plus 1 over 8. I cannot add them if the denominators are not the same. And this is where the golden rule comes into play. I'm allowed to multiply or divide the numerator and denominator by the same number or expression. So I'm going to look at my first fraction, 3 over 4, and I'm going to multiply both the numerator and denominator by 2. And the reason I'm doing that is I'm going to get 6 over 8. 3 times 2 is 6, and 4 times 2 is 8. And then because my second fraction is 1 over 8, I can now add them up. 6 plus 1 is 7. Since both denominators are the same, they're both 8, we write under our 7, 8, and we get 7 eighths. Let's do one more example that is a little trickier. Let's do 1 over 3 minus 1 over 4 this time. Now I need the denominators to be the same. So I think to myself, what's a number that both 3 and 4 fit into? And the number I'm going to pick is 12. So I want to turn the first fraction into something over 12 and also the second fraction into something over 12 because I need the denominators to be the same. This means that the first fraction needs to be multiplied by 4 because then I get 1 times 4, which is 4, and 3 times 4, which is 12. What do I need to multiply the second fraction by? I need to multiply it by 3 so that I get a denominator of 12. 4 times 3 is 12, and 1 times 3 is 3. And now I can subtract my fractions. 4 minus 3 is 1, and the denominator stays the same. It stays as 12. So let's get into our examples now. You'll notice that these examples are trickier than the ones I did just before because these are algebraic fractions. Looking at question A, our denominators are different. So in order to add them up, they need to be the same. So I'm going to use the golden rule. I'm going to multiply both the top and the bottom by 2 for my first fraction. And the reason I know to do that is because 5 times 2 is 10, and then I'm going to have denominators that are the same. What's 2x times 2? That's going to be 4x. So I'm going to have 4x over 10 for my first fraction plus x over 10 for my second fraction. Now we know that the denominators are going to stay the same, so I'm just going to do that straight away. I know it's going to be 10, and 4x plus x is 5x. Now we've added the fractions together, but remember we need to simplify this. I'm going to simplify this fraction by dividing both the top and the bottom by the same number. I'm going to divide them both by 5. 5x divide 5 gives me x. And then 10 divide 5 gives me 2. So I have x over 2. Let's now look at question B. Once again, my denominators are not the same. I need to make them the same number. So what number am I going to make them? Well, I'm going to make them both 33 because 3 fits into 33 and 11 fits into 33 also. So what do I need to multiply? Well, I need to multiply my 3 by 11 to make it 33, which means I've got to multiply the 2a by 11 as well. The denominator and the numerator have to be multiplied by the exact same number. To make 11 into 33, I need to multiply it by 3. Once again, both the numerator and the denominator need to be multiplied by the same number. 2a times 11 is 22a. And 4a times 3 is 12a. And now, because the denominators are the same, our fraction has to have 33 at the bottom. And 22a minus 12a gives us 10a. Now I need to double check and see if I can simplify this fraction, but I can't because there's not a common factor for 10 and 33. So this will be my final simplified solution here. Let's now move on to question C. You'll notice it's getting a little trickier now because our denominators used to have just numbers and now the pronumerals are in the denominator. We want the denominators to be the same. That's the goal here. And focusing on the 4 and the 6, I can turn both these numbers into 12. So my focus here is to turn 4b into 12b, and I'm going to turn 6b into 12b as well. How am I going to do that? Well, I reckon I can multiply my 4b by 3 to get 12b, which means the 2 also needs to be multiplied by 3. And I need to multiply the 6b by 2 so that I get 12b as well, which means the 5 also needs to be multiplied by 2. So 2 times 3 will give us 6, and 4b times 3 does make 12b. 5 times 2 will give us 10, and 6b times 2 also gives 12b. Now, because our denominators are the same, they're both 12b, our final simplified solution will also have a denominator of 12b. And 6 plus 10 will give us 16. You will notice that we have an improper fraction, 16 over 12. Now, when you were given improper fractions earlier in your schooling, such as 16 over 12, you were always encouraged to write them as a mixed numeral. In this particular case, you would normally write it as 1 and 1/3. Now, when you work with algebraic fractions, it's actually better to leave it as an improper fraction. Do not convert it to a mixed numeral. Even though we're leaving it as an improper fraction, we can still simplify this. I can divide both my numerator and denominator by 4. What do I get when I do that? Well, 16 divided 4 is 4. And 12 divided 4 is 3. So I'm going to have 3b below. And we're just going to leave our fraction as 4 over 3b. We're going to leave it as an improper fraction. We'll now move on to question D now. And you can see this could actually confuse some people because the numerators are the same, but that's completely irrelevant. It's the denominators that need to be the same here. So I'm going to convert 7y and 5y into 35y. I want them to both be the same, and I can see that both of them can be turned into 35y. And I do that by timesing 7y by 5. 5 times 7y is 35y, which means I have to times the 3 by 5 as well. 3 times 5 is 15, so that's going to give me the numerator here. Now I need to multiply 5y by 7 to get 35y, which means I've got to multiply 3 by 7 as well, and 3 times 7 will give me 21. So the denominators stay the same, they stay as 35y. What is 15 minus 21? Well, that will actually give me negative 6. So we actually end up with a negative fraction here. Okay, can we simplify 6 over 35? 6 is made from 2 times 3, and 35 is made from 5 times 7, so there's no common factors here. There's nothing I can do to simplify this. But I do want to talk a little bit about this minus sign here. Right now, I could leave this as my simplified solution, and that would be perfectly fine. It's worth full marks. But I can move the minus sign if I so choose. And I am. I'm going to move it to the front of the whole fraction like so. And you're allowed to do this. You can move the minus sign to the front of this is called the vinculum line, so you can move it to the front of the vinculum line. You can have it at the front of the number at the top. You can even have it in front of the number at the bottom. You can have it as 6 over minus 35y. But this is one that I'm really not a fan of. This is the one I do not like. I either like it in front of the number at the top or in front of the vinculum line. So I'm going to rub off this solution down the bottom. Anyway, let's now move on to some more of our questions. We've got question E next. And you can see things are getting a little trickier because you've got two terms with a plus between them. In terms of the denominator, it's not that difficult. All I need to do is multiply my 3 by 2, and then I have both denominators the same. They're going to both be 6. But if I multiply the denominator by 2, I've got to multiply the numerator by 2 as well. And that actually means that I multiply the whole expression x plus 3 by 2. What's that going to look like? Well, my first fraction is going to stay the same as x plus 2. My second fraction, when multiplied by 2, is going to be 2 and then bracket x plus 3. It's very important I put those brackets in because I'm multiplying the whole of x plus 3 by 2. Now, because my denominators are the same, they're both 6, I can subtract each expression above. So I can go x plus 2 minus 2 lots of x plus 3 at the top, and this is all now over one denominator of 6. Now I do want to simplify the expression at the top of the fraction, and what I need to do is I need to expand my brackets. So I need to go x plus 2 and then minus 2 times x will give me minus 2x. And then I need to multiply minus 2 by 3. So minus 2 times positive 3 will actually give me minus 6. Now some of you might notice that this is an opportunity for someone to make an error. It's very easy for someone to have written plus 6 here, thinking that they're just going 2 times 3. You've got to take into consideration that minus sign to the left of the 2. Anyway, this is all now over 6, and we just need to simplify the expression above. What's x minus 2x? Well, that will give us minus x. And what's positive 2 minus 6? Well, that will give us minus 4, like so. All of this is over 6. Now I could stop here, and this is perfectly fine. This is a very good simplified solution. But I just want to go one more step, and this is more for those advanced people that really want to push themselves. I'm going to factorize minus x and minus 4. And what I'm going to do is I'm going to put the minus out the front of the brackets and write x plus 4 like so. And like I said, this is more for those advanced people. Some of you will feel uncomfortable doing this. But a lot of people don't like to have two minus signs here, and they fix that by pulling the minus sign out the front of the brackets and then changing it to x plus 4. Like I said, both of these simplified solutions are appropriate answers, and the one on the right is more for those advanced mathematicians. Alright, so we'll move on to question F now. Once again, we just want to make the denominators the same. We can turn both 4 and 5 into 20. So the first fraction is going to have a denominator of 20, and the second fraction is going to have a denominator of 20. So I have to multiply my 4 by 5, because 4 times 5 is 20, which means I need to multiply a plus 4 by 5 as well. So I'm going to have 5 bracket a plus 4, like so, over 20. And I also need to multiply a minus 3 by something. Because I'm multiplying the 5 by 4 to make 20, then I need to multiply a minus 3 by 4 as well. That's going to give me 4 bracket a minus 3, like so, all over 20. And we're subtracting. Okay, so let's combine this to make one fraction. So we're going to have 5 bracket a plus 4 minus 4 bracket a minus 3, all over 20. So in order to simplify this, I'm going to start by doing some expanding. Looking at my first set of brackets, 5 times a is 5a, and 5 times 4 is 20. So I'm going to get 5a plus 20. And then remembering that this is minus 4 times a, and minus 4 times minus 3. So minus 4 times a is minus 4a. Very important that you don't ignore that minus sign. And minus 4 times minus 3 gives me plus 12. You can see how easy it is for someone to have written minus 12 here by mistake. Anyway, this is all over 20 still. And now we need to simplify the numerator. 5a minus 4a will give us 1a, or just a. And 20 plus 12 gives us 32. So we get a plus 32 all over 20. And here we have our simplified solution for question F. We'll now move on to question G. Getting tougher again. This time we've got a and a plus 1. So how are we going to make the denominators the same? Some of you may have noticed that when you look at the denominators, quite often I multiply them together so that I know what my new denominator is going to be. And a really good example of that, if I go back to question F, I turned 4 and 5 into 20. And I knew that because 4 times 5 is 20. So I'm going to do that here. I'm going to multiply my a by a plus 1. So I'm going to have a multiplied by a plus 1 for my first denominator. And for my second denominator, I'm going to have the same thing, a multiplied by a plus 1. And then you think to yourself, looking at the first fraction, what would I multiply a by to get a plus 1? Well, I would multiply it by a plus 1 in brackets, which means I've got to multiply my 2 by a plus 1 as well. So then my numerator is 2 bracket a plus 1. What am I going to multiply my second fraction by? Well, I'm going to multiply them both by a. I'm going to multiply a plus 1 by a, which gives me a bracket a plus 1. And then I'm going to multiply my 3 by a, which gives me 3a. Let's combine our two fractions now. We get 2 bracket a plus 1 plus 3a. And because the denominators are the same, they're both a bracket a plus 1, I have a single denominator of a bracket a plus 1. Now what I'm going to do is I'm going to expand the 2a plus 1. I'm not going to worry about expanding the denominator, at least not for now anyway. So when I expand my 2a plus 1, I get 2 times a and 2 times 1. So I'm going to get 2a, and 2 times 1 is 2. And then plus the 3a. All of this over a bracket a plus 1. I can simplify my numerator by combining my 2a and my 3a. 2a plus 3a is 5a plus the 2. And then the denominator remains as a bracket a plus 1. Now I could submit this as my simplified solution, and that's perfectly fine. But it's not going to kill me to expand the denominator here, so I might as well do that. So 5a plus 2 remains the same, and then a times a is a squared, and a times 1 is a. Now either one of these simplified solutions are appropriate to submit. Okay, we'll move on to question H now. Once again, my goal here is to make the denominators the same, and sometimes the best way to do that is to multiply each expression together. So let's do that. Our denominator will now be y minus 1, which is my first expression here, multiplied by my second expression, y plus 1. So I'm going to have two fractions with the same denominator of y minus 1 times y plus 1. So let's look at our first fraction here. What do we multiply y minus 1 by to get the denominator we see below? Well, we must have multiplied it by y plus 1, which means that we need to multiply 5 by y plus 1 as well. So my numerator will be 5 times y plus 1. Let's now look at our second fraction. In order for this fraction to have the denominator y minus 1, y plus 1, I need to have multiplied by my y plus 1 by y minus 1, which means that we also need to multiply 3 by y minus 1 as well. This gives us 3 bracket y minus 1. Now we're subtracting these fractions. Let's combine them to make one single fraction. The reason we can do this is because both denominators are exactly the same. So we're going to have 5 bracket y plus 1 minus 3 bracket y minus 1. And then I just have a single denominator of y minus 1, y plus 1. Let's expand our numerator and then simplify. So we've got to multiply 5 by y as well as plus 1. 5 times y is 5y, and 5 times 1 is 5. When looking at the 3, I need to take into consideration that negative there. This is negative 3. So negative 3 times y will give me minus 3y. And negative 3 times negative 1 gives me plus 3 or positive 3. Once again, the denominator remains the same. Y minus 1, y plus 1. Okay, 5y minus 3y will give me 2y. And 5 plus 3 will give me 8. So I have 2y plus 8 for my numerator, and my denominator stays as y minus 1, y plus 1. Now for this particular example, I feel that it is very important that we expand the denominator this time. In question G, I said either one of these simplified solutions was appropriate, but for this particular example, I feel that it's very important that you expand the denominator here. And the reason I say that is when I do it, it's going to make a much nicer fraction. You may have noticed this is an example of the difference of two squares. Both expressions are the same, one's a minus and one's a plus. So how do we expand such an expression? Well, we look at the first term, which is the same in both sets of brackets, and we square it, giving us y squared. We look at the second term, which is 1, all the same for both sets of brackets. They're both 1, and we square that. 1 squared is 1. And then we put a minus between them. Now, if you're not sure how I did that, I taught in a previous lesson how to expand an expression using the difference of two squares. Alright, so you'll need to go back to that lesson. The next thing, the numerator will actually stay the same. It will stay as 2y plus 8. And this is our final simplified expression. Okay, moving on to our last two questions. Looking quite tricky, especially question J. Look at that. Now, looking at the denominators, I want them to be the same. I can see they're not at the moment. And if I multiply them both together, it's going to make a really big expression. And what I'm going to do is I'm going to encourage you to actually do some factorizing first. Okay, and we're going to do that for both questions I and J, and it's just going to make your life a little easier. So what do I get if I factorize this first denominator here? Well, I can factor out a common factor of x. And x times x will give me x squared. And x times 2 will give me 2x. So now looking at my second fraction, it has 2 as its numerator. I'm going to factor out x again for my denominator. And then x times x will give me x squared. And then I need x times minus 2 to give me minus 2x. Now that I've factorized, I can see that I can multiply the left side by x minus 2, both the denominator and the numerator. And for the right side, I'm going to multiply them both by x plus 2. Now, if I hadn't factorized first, my first fraction here on the left would have had to have been multiplied by x squared minus 2x. But by factorizing first, I now only had to multiply it by x minus 2. Alright, now that we know that the denominators are the same, I now combine my two fractions. I have 3 bracket x minus 2 for the first fraction, and I'm subtracting 2 lots of x plus 2 from the second fraction. And I have now just a single denominator of x, x plus 2, x minus 2. Alright, so let's expand the numerator now. We're going to multiply 3 by x and then by minus 2. 3 times x is 3x, and 3 times minus 2 gives me minus 6. Next, I'm going to go minus 2 times x and minus 2 times plus 2. So minus 2 times x is minus 2x, and minus 2 times plus 2 gives me minus 4. And the denominator remains the same, x, x plus 2, x minus 2. Now when I combine like terms, 3x minus 2x is just x, and negative 6 minus 4 gives me minus 10. And then I have a denominator of x, x plus 2, x minus 2. Now looking at the denominator, I can see something that looks like the difference of two squares. I have x plus 2 and x minus 2. So that's going to help me if I expand it. So the top of my fraction will remain the same. It will remain as x minus 10. And then let's just focus on the x plus 2, x minus 2 first, and we'll worry about the x later. So when two expressions look the same, except one is a plus and one is a minus, then we square the first term and square the second term. So we square x, giving us x squared, and we square the 2, giving us 4, and then we put a minus between them. Okay, now I said I'll refer to the x last. Now, because of that x, we just need to put our x squared minus 4 in brackets and put the x to the left of that. And we'll go one more step. X minus 10 at the top. And let's expand our brackets. X times x squared gives us x to the power of 3. And x times minus 4 gives us minus 4x. And that is our final simplified solution here. Finally, moving on to our last question, question J. I'm going to do the same thing as I did in question I. I'm going to factorize my denominators before I try and make them the same. Now you may have noticed that these are monic quadratics, and if you don't know how to factorize monic quadratics, you need to go back to a previous lesson where I taught you how to factorize monic quadratics. Now we are looking for two numbers, and when we look at the first fraction, the two numbers need to add to make the positive 2, and they need to multiply to make negative 3. So what two numbers do that? Well, positive 3 and negative 1. 3 minus 1 is 2. 3 times negative 1 is negative 3. So for our first fraction, we're going to have 2 at the top, and then we're going to have x plus 3, x minus 1 in brackets. That's where this plus 3 and minus 1 go. They go in our set of brackets. Let's now look at the second fraction. We're looking for two numbers that add to make 5 and multiply to make 6. And those two numbers are positive 2 and positive 3. 2 plus 3 is 5. 2 times 3 is 6. That gives us our second denominator, x plus 2, x plus 3. We can see that our 2 and 3 have carried down into our set of brackets. Now that we've done that, you can see that they both have an x plus 3. So all I need to do for my first fraction is I need to multiply it by x plus 2. Both the bottom, the denominator, and the top, the numerator. And for the second fraction, I need to multiply both the top and the bottom by x minus 1. And if I do that, both denominators are exactly the same. Let's go to our next step. So at the top we're going to have 2 times x plus 2 because the number actually needs to go to the left of the brackets. And then we're going to add this to one lot of x minus 1. And we're going to put all of this over a single denominator of x plus 2, x plus 3, and x minus 1. So let's expand the numerator and combine like terms. We've got 2 times x and 2 times 2. So 2 times x is 2x and 2 times 2 is 4. And then we need to multiply positive 1 by x as well as negative 1. So 1 times x is 1x, or just x. And 1 times negative 1 will give us minus 1 here. We're not going to expand the denominator yet. In fact, I get the feeling I'm not going to even expand it at all. Okay, and quite often that happens. Let's now combine like terms. 2x plus 1x is 3x. And 4 minus 1 is 3. So we get 3x plus 3. And then I keep my denominator the same. X plus 2, x plus 3, x minus 1. Now I'm not going to expand this, and the reason I'm not going to expand it is it's not going to come out very nice if I do. So it's actually probably better that I leave it in this factorized form. There is one thing I'm looking for. I'm looking at the top here, which is 3x plus 3, and I'm just thinking to myself, can I factorize this and do some cancelling? And I'll just show you in green. I can factorize 3x plus 3. That gives me 3 bracket x plus 1, which actually isn't going to help me, but I did want to just double check. The reason being, if this here was not x minus 1, let's say this was x plus 1, then factorizing would have helped me. I could have actually done some more cancelling here, but it's not going to help me at all. So I'm just going to leave it like this. It's perfectly fine to leave the denominator factorized like this. In fact, quite often it's encouraged. The reason we encourage it is in case you can do some more cancelling, which we can't in this case. Anyway, that concludes our video on example 2. Remember to read the description below for links to workbooklets that relate to this video.